Hi everyone. So today we're going to work on what are called complex numbers. And this is going to be brand new for us because we've never talked about complex numbers before. And you think you know every single number that exists, but we don't up until this point. So what we're going to do today is we're going to identify what a complex number is, we're going to graph it, and then we're going to perform some operations on it. So there are two things that we don't know the answers to right now: square root of negative numbers and how to divide by zero. So the square root of a negative number, they came up with a solution, and they use it as a representation of how to deal with it. So when you square root a negative number, we usually get, like, let's take the square root of -1, okay? We don't know what the answer is to that. Right now, we say there's no solution. A lot of times you may see, if you put it in your calculator, you're going to say non-real solution, things like that. Well, they came up with something called I. Stands for imaginary numbers. Okay. Now, imaginary numbers are what we're going to use to represent that negative underneath the square root sign. In fact, I is actually equal to the representation of the square root of -1. So what does that mean? That means that we have a whole new kind of set of numbers besides the reals, the rational, the irrationals, the naturals, the wholes, all of that, integers. But now we added something else, and that's called the imaginaries. Okay, so when we're looking at imaginaries, they basically represent the square root of a negative. So how we're going to handle this is, if, let's say, I had the square root of -4, okay, we're going to think of it as two separate things. We're going to think of it as the square root of -1 times the square root of 4. So we're kind of taking out that negative, and we're going to separate it, and we're going to deal with it as two separate problems. So we know the square root of 4 is 2, and the square root of -1, we're going to pull out as I. Okay. So now we have this representation of the square root of a negative number. Okay. All right, so let's take a look at some of these simplifying. Square root of -18. Well, we're going to take this as the square root of -1, square root of 18. So I, square roots of 18. Now, if you know how to simplify the square root of 18, some of us do, some of us remember, it's going to look like 3i square root of 18. Oh, sorry, 3i square roots of 2. Okay. All right, square root of -25. Square root of -1, square root of 25. Square root of 25 is 5. Square root of -1 is I. Remember, the order in which we multiply things doesn't matter, so I could put I square roots of 5, or I 5, or 5i. Usually we talk about it in terms of 5i. All right, take a minute, pause the video, try problems 3 and 4. All right, let's see how you did. So if you got I square roots of 12, great. If you remember how to simplify the square root of 12, it would be 2i square roots of 3. And then I got I square roots of 7. There's nothing much you can do with the square root of 7. Okay. All right, so now that we've added these imaginary numbers to take a look at the square root of -1, we actually have more numbers than we did before. So right now, we know what I would refer to as counting numbers. Putting it on the bottom because those are the most basic numbers. And those are 1, 2, 3. I would call them Sesame Street numbers because those are the first numbers you learn when you're in, preschool. And if you put the counting with 0, you get whole. And if you put wholes with negative numbers, negative whole numbers, you get integers. If you put integers with fractions and decimals, you get rationals. And if you put rationals with irrationals, you get reals. Okay, so those are all the numbers that we know right now. But over on the side here, we have imaginary. And these are square roots of -1s. And when you put the imaginaries with the reals, you get every number that we know at this time called complex. Okay, so those are all the numbers in the world. So we added the imaginaries and got the complex. And the complex are any number that can be written as a plus bi, where a is a real and bi works with the imaginaries. Okay, all right, so let's define that a little bit more. Imaginary number, or sorry, complex number, is any number in the form a plus bi, where a and b are real numbers. Oh, I don't know what just happened here. There we go. And b does not equal 0. Okay. Imaginary and reals together made up the complex. Okay, so I have a different graphic. So that's what I would call a stepladder graphic. This is a circle graphic, where naturals and whole are the most basic, so they're the innermost. Then you have wholes, integers, rationals, irrationals, together rationals, and you get real. And then you have imaginaries, a plus bi, and then complex. Okay, so complex are all the numbers that we know at this moment in time. So what we want to be able to do today is graph those and perform operations on them. So we learned a whole brand new number today. So when we graph complex numbers, we get a whole new coordinate axis, where the horizontal axis are the real numbers of the a plus bi form, and the vertical axis is the imaginary, or the I part of the form. So let's say I wanted to graph 7 plus 2i. I'm going to go over the 7, there it is, and I'm going to go up to I. Okay, so my final answer is right there. Okay, so think of it as graphing an XY in ordered pair. You go left and right the complex, left and right the real, or the A, and up and down the imaginaries. Let's try another one. I want to graph 5 minus 2i. I couldn't get the graph to fit on that page. All right, so 5 minus 2i. So I'm going to go over to 5, and then I'm going to go down negative 2i. So that's right here, and that's my answer. Okay, 6i. Well, I'm not going anywhere left or right because I don't have any reals. I only have an imaginary, so I'm only going to go up 6. And there's our point. Okay, so you would need special coordinate planes to graph a complex number. All right, so let's put these together. When you're adding and subtracting complex numbers, you're going to add reals with reals and imaginaries with imaginaries. Because together they're going to form the answer of the complex. If you try and to put them together and create like 5 plus 4i is not 9i, because it's a real and you can't put an imaginary. It's like trying to take apples and oranges and creating a whole new fruit. Doesn't work. We're not making fruit salad here. Okay, so we're going to take the reals with the reals. So 7 plus negative 3, and that's going to give me 4. And then we're going to do the i's. Negative 2i and positive 1i give me negative 1i. And that's your answer. All right, let's try this one. I'm doing 1 minus 3, so that's going to be giving me negative 2. And then we're going to do positive 5 minus negative 2, so that's going to be positive 5i plus 2i gives me 7i. And that's how we're going to leave it. Okay, All right, let's try, why don't you guys try 2 and 4 on your own, see if you get the right answers. All right, let's see how you did. Okay, I got 3 plus I for 2. All right. Okay. All right. And then the last one, I only got 12i because the 8's cancel each other out. Okay, so with adding and subtracting, it's kind of like doing variables. You know, you add the coefficients, you carry the I along. So i's with i's, like terms kind of thought process. Multiplying is the same idea, that you're going to use the same kind of process as we did when we multiplied binomials, that distributive property, all of that's going to hold true, okay? But you can multiply a real with an imaginary. Okay, so just like if I did 7 times 2x, we would get 14x. But in adding and subtracting, we would just leave it as 7 plus 2x. So think of it that way. All right, so if I'm going to do 7 times 2i, we would get 14i. All right, so we can multiply the numbers. Now, here's the thing about imaginaries. We have to think about what happens when you multiply them together. So let's talk about I times I. So I is the square root of negative 1. It's that representation. So if I go I times I, or I squared, that would mean negative, or square root of -1 squared. Now remember, when you square a square root, the square root goes away. It's -1. I times I times I is I cubed. Another way to write that is I squared times I. Well, that's -1 times I, which is -I. Let's do one more. I times I times I times I. That's I to the 4th, which is just I squared times I squared, which is -1 times -1, which is just 1. So I is the square root of -1, I squared is -1, I cubed is I to the 4th is 1. Okay, now if you go past I to the 4th, watch what happens. That's 5 i's. I to the 5th, which is just I to the 4th times I. Oh, I to the 4th is 1 times I, which is just I. Ah, we're back at the beginning. It's circular. After I to the 4th, it all comes back. I to the 5th is I to the 6th is -1, I to the 7th is I to the 8th is 1. It makes a big circle. All right, so why do we care? Well, let's take a look at this. We're going to distribute, so this becomes -15i plus 6i squared. Well, I squared is -1. So -15i plus 6 times -1, or -15i minus 6. Let's try another one. 21i squared. -21, because I squared is -1. Okay, let's try this guy. Now we're going to do our split, whatever way you multiply things. So that's 8 plus 10i minus 12i minus 15i squared. Okay, I squared. That goes to -1. So that's 8 minus 2i. Okay, so I just added these two together, combined like terms. Okay, so this is -15 times -1. So that's going to be 8 minus 2i plus 15. Or 23 minus 2i. Now, if your question is, well, it always just changed the sign of that last term, if it's I squared, the answer is yes. So basically, I squared changes the sign of the number in front of it. So 30i squared is going to be negative 30i, negative 30. Negative 12i squared is going to become 12. Okay, so it's just going to change the sign in front. All right, so try 2, 4, and 6 and see if you guys get the right answer. All right, so 2, I got negative 3 plus 11i. 4, I got negative 17, 20i. And 5 is 34. Notice in 5 that the middle term here, that the i's cancel out. Okay, and that's important because that has a name. That is called a conjugate. So conjugate, so let's say it starts out with a plus bi. Its conjugate would be a minus bi. Because when we multiply the two together, there's no middle term. And that's the whole point of the conjugate. Okay? That when you multiply them, the middle term cancels each other out. Okay, so let's call this the middle term cancels out. Okay, so let's talk about dividing. Right? Now, dividing, again, is a problem child. It always is, because we can't have a square root on the bottom of a fraction. And if you're listening to anything we've been talking about, I is a square root. It's the square root of negative 1. So if there's an I in the bottom of a fraction, he's got to go. We can't have an I in the bottom of a fraction. So there's two types of problems. One where it's just an I, and one when there's a complex. So if there's just an imaginary, or if there's just a complex. All right, so what we have to do in the first one is get rid of the I in the bottom of the fraction. We're just going to multiply top and bottom by I. Because I times I is I squared. So we're going to distribute. Over 3i squared. Okay, so I squareds become negative 1. And there you go. No more i's in the bottom of the fraction. Can you take a 3 out of all of those? Yes. In fact, you can take a negative 3 out of all of those. So this will become negative 3i plus 4, if you really wanted to go that far. All right, so let's try this one. Now this is a complex on the bottom. How do I know? Because it's a real with an imaginary, so 3 plus 4i. We're going to multiply top and bottom by the conjugate, which means we're going to multiply top and bottom by the exact same thing, except the sign in the middle is going to be the opposite. So 3 minus 4i, top and bottom. Okay, we're going to multiply, which means we're going to do whatever method you're most comfortable with, split, distribute, FOIL, box, whatever. So this becomes 15 minus 20i minus 6i plus 8i squared all over 9 minus 12i plus 12i minus 16i squareds. Okay, so both I squareds here are going to become negative 1. All right, so the numerator, the top, is going to be 15. So that's going to be minus 26i minus 8. Again, you can do that all at once if you wanted to combine them. That's fine. I just want to make sure everybody understands where everything's coming from. Okay, if we look here, the 12i's are going to cancel. So we're going to get 9 plus 16. Okay, so 15 minus 8, 7. So 7 minus 26i all over 25. Okay, all right. Take a minute, look at that, and try 2 and 4 and see if you get the same answers. All right, so 2, and do the whole shebang. You're going to multiply top and bottom by 1 plus 4i, which is the conjugate. Again, same thing, opposite sign in the middle. All right, I got negative 10 plus 11i over 17. Then in the denominator, the next one, multiply top and bottom by I. We're going to get 4i plus 1 all over the negative 6. Okay, guys, learned a brand new type of number today. So if you have any questions, please let me know. Have a great rest of your day, and I'll see you again real soon.